Getting ready to dump these ROMs. Yes, I have a dinosaur of a setup, but you know what? It works, and it works well. Got my PromLink disk in there, so I'm going to switch over to A drive. PromLink. And put this in setup mode, or remote mode. Okay, we're established. So let's set this baby up. Programmer type is 29B with UNI pack. Done. And we're going to go to select device type. We're at Motorola 19. Motorola, we are 2708 if we can find Motorola 2708P 2. And of course that one's covered. Oh, it's 2708. I don't know. We'll see. Let's just, I want to double check something. I want to just double check. Motorola 19. And 2708 is 2708P, so let's just go with it. Okay. And we'll put this guy in there. This is D1. And I'm going to go ahead and throw my ROMs disk in the drive. Load RAM from device 3. Begin loading. Okay, we're going to now save that, create a file, and we're going to call it D1. Okay, that one is saved. Now we will do NP1. F1, load RAM from device. Okay. That was NP1. Okay. Now we'll do H1. H1. And I'm going to go ahead and do the rest of these 10 or 11. I'll be right back. Okay, so I want to show you what I found when I did a comparison from the ROM set here. I put them back in the board. The ROM set here to a known good ROM set like this. I'll show you what I found. I had 3 ROMs that did not match. See, what I did is I have the files, the good files for this, and I matched what I dumped out of these to those. And I had 3 that did not match, and all 3 of them, the very first byte of data in the ROM, address 0000, was all wrong on the 3, which is it's just strange that it's that bit. But you can see this one, the first byte of data in D1 was D5, and it's supposed to be 04. The rest of the ROM is fine. It's just the first byte went bad. And on this one, the bad is A1, and it's supposed to be 20. And I think what's going on, it's just strange that it happened in the first byte of address. But it's supposed to be 04, so that would be 4 zeros, 0100. And instead, it's D, which is 1101, and then 5, which is 0101. So it's like a lot of the zeros turn to 1 over here, and then the 0101, or 0100, one of the zeros on the end floated up to a 1 to make it 5. So I think, I mean, it's strange. I don't think this is a different version of ROM. I think these are just bad. So I'm going to reprogram these 3 and see what we get. See if that makes a difference. It's 3 bytes of memory. You know, it's 3 bytes of program that's wrong. It could be enough to throw it off. Who knows? Anyway, I'm going to program those, make them right, make them be what they should, and we'll go from there. See what that does. Hey guys, we got some funny business going on here. I need to plug in the camera before it dies. Alright. I'm going to shut this down and remove this guy. Sockets are nice for when you want to do some testing and fooling around with stuff. Now let's restart. Still got blank white screen. And if you look at the scope, this is 128V and it's doing nothing. But watch, I can sit here and play with reset and get it to work. See that? There's 128V. Now if I come up here, that is 32V, I think. 32V on 11. Yep. And 10 is 64V. So there's 32. Nine is 64 and 10 is 128. $64, 128. $128 is not, that's not quite right, is it? 128 on 10. 7, 8, 9, 10. This is 128, according to the schematic. 7, 8, 9, 10. That's 128. It's supposed to be big. See, it goes to a different shape. And I don't know why. This is super, super weird how this is messed up. And it'll go into that. Anyway, this is the output of the LS27, which I have replaced. I know this chip's good. I'm going to turn it off, and I'm going to take that output out of circuit. Just fold the leg up, take it out of circuit, turn it back on. Okay, now here's 128V. Let's get it. Okay, if I hold reset, there's 128V. If I hold reset in, that is 128V. So we have 32, 64, and one. No, this is 128. Right? Yes. And this is 64. 64, 128, 32. And that's the output. So you see there is an output when it's out of circuit. But if I put it in circuit, there's no output. Yeah. 32, 64, 11, 9, 10. That's been throwing me off. 11, 9, 10. That's how it goes. And there's your output. So what I want to do is turn it back off. I want to remove this guy. Put that back into circuit. Turn it back on. And of course I'll probably get nothing here. But if I'm going to hold reset, I'm just going to hold in reset. And okay, if I hold reset, I do get my output. Okay. If I hold in reset, this is a weird problem. If I hold in reset, it'll work and count. Let me see something. Where are my... It's not decoding. It's a sync problem. It's in the sync area. It's a sync problem, and I'm having a hard time finding this sync issue. Wait a second. Just some good old-fashioned poking around here. You know, this chip is kind of suspect right here. Vertical blank is on 5 of A5. 5 of A5, vertical blank. There's your vertical blank signal, which is non-existent. Okie dokie. Horizontal stuff is all good, I believe. I'm just going to have to go through the whole sync chain. It's a sync problem. I can't believe I'm having this much trouble finding the sync issue. I'm going to look, it's right through here. I'm going to look at everything into here. This whole area right here. I'm going to go through it signal by signal, bit by bit. Okay. Vertical sync. Let's start there. V-sync, which I do not have. Do not have V-sync. That's vertical sync. Flip. Which flip blows me away that it's I don't understand why flip is toggling. Two input circuits. Jesus, I can't see this schematic. E6, F6, F6. Oh, that's 11. F6. Okay. And I'm gonna go ahead. I'm gonna use. I mean, most of these are simple gates. You know, so I can use the whole 4 channels on an 11. I can, because it's 3 input, 1 output. F6. F6. Okay. 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 So, got all 4 of these guys in. The 11, F6. Let's do this one first. Input. Come on, man. They don't. It's not easy to do this, I'll tell you that. All right. All right. No, that looks good. It's 11 is a 3 input and whenever it's high it'll pulse whenever all 3 are high. So the H04 11 out to 10. H04. I'm just checking this inverter right here. That looks good. And on to F6. Back to the F6 chip. 1 and 2. Pins 1, 2, and 3. No, 1, 13 out to 12. Looks good. F6. F6. Alright. 13. Okay. Go back to this guy. I got another one of these inverters to look at. 13 out to 12. Okay, looks good. Uh, 08 D8. Zero D800. Ten 9 out to 8. I don't need that guy for this. Oops. So 10 and 9 out to 8. 10, 9, to 8. And this is a NAND, a not AND. So it'll be high, and the only time it'll be low is when they're both 1. Yeah, it looks good. The only time the output will be low is when both inputs are 1. That looks fine. Let's go over to 1, 2 out to 3. And same thing, both of them are a 1, you get a 0. Looks good to me. Yep, okay. And that is okay. Now we got a D4 0 D4. Goodness gracious. D4 is that? No, it's not D4. I can't tell what that is. D8 00. I think it's the same thing. Five and 4 out to 6. It's drawn different in the schematic. It threw me off. Why would they do that? Try to confuse you. And the only time it's 0 is when they're both 1. So the periods of time when they're both 1, it is 0. Yeah, See, 1, 1, 0. Not both 1, so that's 1. 1, 1, 0. 1, 1, 0. Okay. H708. Let's look at H708. So far, so good. H708. 9 and 10 out to 8. This is an AND gate. Vertical blank is on 10. Pin 10. There is no vertical blank. That is the failure. There's no vertical blank. And 10 is vertical blank. Yes, 10 is vertical blank. And because there's no vertical blank, there's no vertical sync. And vertical blank is created right here. And it's just NANDed by A5, the 260, which I have already replaced. Oh, son of a gun. What? Everything comes back to 128V. Everything comes back to 128V. I'm going to have to analyze this 191. I need to know once and for all, is that thing working? Should have done this a long time ago. But we're getting there. We're moving along. We're just kind of snail pacing it. We'll get there, but I need to put my analyzer on that 191 because I need to know, is that thing actually working? You know, is it being stopped from working, or is the clock not right? I'll tell you another thing that's weird is, why is flip toggling? Flip should just be flip the screen, you know, player 2 or whatever, toggle or go high, go low, whatever, for cocktail mode, or, you know, flip the screen, flip. Why is that toggling? That's throwing me too. I programmed 3 ROMs, by the way. 3 known good ROMs. I erased them and I programmed them with the right files, and it did make a bit of difference, but you know, we have a weird sync issue. A stinky sync. Our decoding is fine. Address decoding is 100% fine. It's is it 100% fine? Hold up a second. Is it 100% fine? I don't think I ran CalcSig on the ROMs that were in here. That's what I need to do next. Is I need to, that'll tell me, because I've got all this information about what This, yeah, all I have to do is take these original ROMs that I ran the fluke tests on, put CalcSig through them, and see if they verify to this. The ones that were wrong, see if they verify to that. And if they do, then okay, decoding's good. If they don't, then I do have a decoding issue. And that could cause weird stuff. Before I do anything, I need to do that. I need to verify that. I need to verify that my decoding for these ROMs is good, is right. So all I'm going to do is take the original files, run them in CalcSig, and see if they match. So I'm going to go ahead and do that. Stop, do that, and then move on. That way I'll know I can eliminate decoding once and for all. So let me do that. Alright guys, and here we are back again. This is normally one of those things where I'd say, yeah, I analyzed this chip and it seemed fine, so I moved on. Well, this new way of doing things, I'm going to record everything. So this is the 191 that I said I was going to look at, and we're going to hook up to it and look at it. The UN90 is right there, B4. I just want to eliminate it. Is this thing working as it should? Should 128V be pulsing? Therein lies the question, isn't it? And then if it is supposed to be pulsing, if it's not, I don't think it's this chip. It's got to be something in its fan out. Something that it's driving has got to be holding it to a state, I would say. I don't know yet. That's what we're doing. We need to just look at this guy. But I need to know, and this schematic is so small I can't see it. I got to put on the Coke bottle glasses. We have an enable on 4. That'll be number 1. That'll be our 0 input. Pin 4. And we're going to come around. Number 4. Okay. Our clock is pin 14. That'll be number 1. 14. We have a up-down input on pin, well, it's a down input actually. .191s are an up-down counter. So it will either count up or down. You know what? I wonder if this thing, because flip, this is very interesting. Flip is toggling, and that's our input. The flip signal is the input to the up-down count. If it's toggling, this thing is constantly counting up and then down, and that most significant bit might not be toggling because of that. I'm telling you, that flip signal toggling is not right. That can't be right. That thing might be stuck in between counting up and down, and that highest, the most significant bit never toggles. Let's put that in the back of our head. I'm still going to look at this. I want to know what's going on. But that's a theory that just jumped out at me. So the next one is going to be that bit on pin 5. Okay, and now we're going to do our count bits. Our inputs are floating, and the pull up and the load pin is pulled high. So it'll never load. It's not ever loading an input. But it starts counting at 1111, I would imagine. I mean, does this thing automatically load when it's fired up? I don't know. 3, 2, 6, 7. Those are our count bits. 3, 2, 6, and 7. Three, 2, 6, and finally 7. The 191 is hooked up. I can take the Coke bottles off. I'm going to fire up the analyzer. I'm going to go ahead and fire up the board. LED is on, means the board's on. I'm going to go ahead and give you a view of my scope, and I will talk about what's going on. I'm going to move you way up over here. Try to put you right in a good spot. Try to do this. This would be a little difficult maybe for me, but I'm gonna set you up right in front. Okay. First off, I have to set it up. Trust me, this is difficult with the camera right in the way. Okay. But I want you to have a good look. We're not going there, we're going here. You gotta format it. We will name this guy, this was our enable. So we're gonna modify, call it, and it's enabled low, I think. Where is it? Right here. I can't see. I gotta put the Coke bottles back on because I cannot see that. Bear with me. It is enabled low, yes. So it's enabled low. So I always put the little that in enable, and that is the very first bit. Okay, and our next bit was the clock. We will call it clock, and it's the second bit. Doesn't this have a clear pin? Apparently it does not have a clear pin. Okay. The next one is up down, so we will modify it and call it up down. Oops. Done. Modify. Up, down. That's the third bit. Now we just have our 4 outputs. Come on, this is B. Q, space, B. And we'll call this guy QA. Okay, and this is 4th bit. This is 5th bit. Come on, damn it. Alright. And okay. Whew, 2 more. This is QD. QD. Alright, there you go. We are formatted. And of course, D is the most significant, A is the least significant. So let's go ahead and run it repetitive. Always delete everything. I always clear it out. We're going to go overlay. Enable. Do I really need to do that as an overlay? I don't think I do. Let's do everything sequential. Start over. Enable. Clock. Up, down. QA. A, B, C, D. Alright. Oh man, it's killing me. Up, down is low. Enable. Enable. The enable goes low. We have a clock pulse, and this least significant goes. Huh. See, up down is pulsing like that. QA looks goofy, don't it? Looks like B and C are just the absolute inverse of each other. Now this is just weird. I don't know. It's kind of hard to make any sense out of this, to be honest. The way an up-down counter works, it's enabled if there's a clock during the enable, and depending on, oh, you know what I can do? Oh, this will make it so much easier. I can combine these to I can do a decimal number. Let's go to format. Alright, we're going to turn off label. Come on. Alright. We're just going to call this out. And that's 4 bits out. 1, 2, 3, 4. Alright, now what we're going to do is go here. I'm going to go ahead and delete all of them again. Enable, clock, boom. Now we're going to overlay the output. $12, $11, $10, $11, $12. Okay, it is counting down. 10. Now it counts up because this is low. 11, 12. And it's low, it counts down apparently. So when it's low, it counts up. When it's high, it counts down. 11, 12. The most significant bit during all of this is always high. I see 10, 11, 12. So the most significant bit is always high. Now what happens? Let's hold reset. Reset takes it to a 0. Now it's toggling. Now you're getting 1s and 0s on that most significant bit. So that just tells me, and look at the enable. Look at the enable, how clean that enable is. And then you let it go and it just goes wacky. So maybe my problem, maybe I need to look at that enable, and that's the other 191. That is the comes from the ripple out, the ripple bit. You hold reset and that enable goes absolutely perfect. You let it go and it goes wacky, and then because it's wacky, right now the most significant bit is stuck low. Very weird. Okay. What makes that enable do that? Okay. 4H and 32H and horizontal blank. Are all part of A6 74. Okay. And I hold reset and it just looks perfect. These 191s are not the problem. I think it goes back further into the sync chain. I think I need to look at the horizontal counts. I reset the thing. I hold it in reset and it does this. The moment that I let this thing this really shouldn't have anything to do with sync. It shouldn't. Oops. Okay. Let me try. I'm gonna try triggering on. Oops. I'm kind of surprised this thing's counting at all, because when it's enabled, there's no clock pulses. How is this thing even counting at all? Huh. But I was right, though. I mean, my theory is right about how this thing toggling is making it go up and down and up and down and up and down. But that still doesn't... This is a total baffler to me, guys. This makes no sense. I think I have to look at the data sheet on a 191. Because this doesn't make sense to me. How is it doing anything? How is it counting? What am I missing here? How is this thing counting with no clock pulses while it's enabled? Yet, there it is. Alright guys, I'm going to have to cut away because I feel like I'm wasting time right now on this. What a freaking mess of a problem here. Alright, I'll be back.